We have finished the syllabus. Okay. Uh, so first I want to go through your UCSC notes because mostly we followed our notes. So therefore let's quickly go through the UCSC notes and then move on to the 2020 4 paper. Okay. So that is the idea. I'm not going through our notes again because we have done it. Okay. Right. So we started with the system concepts for modeling. That is basically a revision on object-oriented programming, right? So that I don't want to spend too much of time because it's basically a revision on object-oriented concepts like what is a class, what is an object, what is messaging, of course, right? What is inheritance, what is polymorphism, that kind of things. And also what is UML and so on. Okay. Right. So remember UML is Unified Modeling Language, which is a modeling language for analysis and design. Analysis and design. Right. So what is a class? What is a object? What is a method? Anyway, if you have any doubts about these things, now you can talk now. Right. So we can discuss because we have time. And your exam is, I think, delayed by I think two weeks, right? Right. So therefore, if you have any questions, if you need any more details, okay, any doubts you want to clarify, because at the end you must not have any doubts, right? All your doubts you must have resolved, right? So what is encapsulation? Special case of encapsulation called data hiding, inheritance, polymorphism. So what is dynamic binding or late binding? So do you have any questions about these things? Of course, don't tell me explain polymorphism, right? It doesn't work because I have explained polymorphism. But if you have any specific question about polymorphism, specific question about inheritance, right? Specific question about encapsulation, right? So you can't tell me, ask me something like, can you do a revision on object oriented? No, that doesn't work. Because I have done a revision on object oriented concepts. The recordings are there. Okay. So basically, when we model so that we can utilize these concepts to develop the system because once you design it, you need to develop using these concepts. So why do you have these concepts? Because then we can develop it in a modular manner, right? Reusable, maintainable, handle complexity through divide and conquer modularization because we break functionalities into classes, right? So you need to compare with structured programming. Like even UI, button is object, like checkbox is object, and we can use frameworks, right? Object-oriented manner, like libraries, like for example, database libraries, file handling libraries, UI libraries, and of course the frameworks, MVC frameworks, and so on. So all these are facilitated by uh, object-oriented programming concepts. Okay, right. So these are classes, object, right? What is a class? Now you must have the world's best answer for what is a class. What is an object? Okay. Right. So attributes, behaviors, another name for behavior is a service. Your attribute can be a property or state. Okay. So this is how you model a class, attributes and behaviors. Your attributes will be either instance variables or class variables. Behaviors will be either instance methods or class methods. So you should be able to take that decision now. Should it be an instance variable? Should it be a class variable? Should it be instance method? Should it be a class method? Okay. So then you have that confidence to develop a software. What is the connection between class and object? So class act like a factory, or we model classes to represent objects, then your class can be used to create objects in the runtime. So likewise, you must talk to yourself also. Make a small mind map. And if you have any doubts, search for that. Go to YouTube, ask ChatGPT. And so what is messaging? Messaging is an object calling behavior of another object. Okay. Messaging. So you can send parameters. Sometimes when you call a method, messaging means call a method of another object. Or you can call method of your own object. So that is you are sending a message to yourself. Right? Right. So any questions you are having? So then what is encapsulation? So basically creating object is encapsulation. So different functionalities are encapsulated into different classes and later different objects at a runtime. So special case of encapsulation called data hiding. Make your attributes private and let them access only through behaviors or methods. Okay. So then inheritance. So you must have the perfect definition of what is inheritance. Creating hierarchy of classes so that classes below the hierarchy get it or inherit non-private attributes and behaviors. Okay. So I told you it's better to use subtype, supertype, yeah, rather than parent and child. Because parent and child is not the best terminology for inheritance. Okay. But yes, casually we use, even examiner will use. So therefore, the better word is generalization, specialization. Right? Super type, subtype. Right? So then we look at the polymorphism and dynamic binding or the late binding. So this is the most important object-oriented concept. Right? I told you this is the least understood concept as well. So it's polymorphism that let us use frameworks. Right? The Hollywood principle, inversion of control principle, all these are possible because of polymorphism. An ability of an object to take many forms. What are those many forms? Its own form or any of its supertype forms. Or if that class has implement any interface or interfaces, any of those interface forms. Right? So it facilitates open close principle. Right? Your code must be open for extension, closed for changes. Now you must have serious discussion about those things with yourself, others. Right? So what is overloading, method overloading, operator overloading. Of course, function overloading is just same as pretty much the method overloading. Okay. So then what is overriding? So though your class has written methods to the super type, say you are expecting account object, but if when account object is expected, you can send a savings account object, super savings account. And if you have overridden a method in your super savings account, which you call in your whatever that process method where you expect account, that overridden method will be called. That is called dynamic binding or late binding. So by the time you create your framework, they never had super savings account. You wrote your code to the account, but they have overridden it and call your method. Uh, and your method you call a method in the super type. In the runtime, actually their subtype overridden method is called. So you need to think about it. If you have any doubts, you can talk. Right? I can help. Okay. If you had specific, but by this time you must have tried out these codes, examples. So then only you may have doubts. Otherwise, you can only question you can ask is Can you explain polymorphism again? No, I don't do that. I don't do that. If I explain it again, I will explain the same way. But if you have any specific questions, I can explain, okay? Those specific points. And so remember, it's not compile time. The polymorphism is runtime. Runtime. That is called late binding. Right. So then we look at the UML, Unified Modeling Language, because in object-oriented programming, we need to heavily model. There's upfront additional work, which the benefit you get late. Right? Handling complexity, better maintainability, better reusability. But upfront, you need to model it. You can't just start coding like structured programming. You need to identify classes, how they are interrelated, right? What are the relationships, inheritance hierarchies, right? Possible message passing sequences. Right? So remember now we have UML2 and some diagrams were introduced in UML2, right? Right. So we subdivided all the UML diagrams into two categories: structured diagrams versus behavioral diagram. So class diagram, deployment diagram, uh, component diagram. So those are structured diagrams. Almost all the other things, use case diagrams, sequence diagram, right? State diagrams, activity diagrams, those are all behavioral diagrams. It shows dynamic behavior, not static structure. You can see class diagram, component diagram, object diagram, deployment diagram, package diagram, composite structure diagram, profile diagram. So those are structured diagrams. All the others, activity, use case, state, sequence, communication, interaction, overview, timing. So those are all behavioral. So first of all, you must have that big picture, right? So that gives you the confidence. That gives you the confidence, right? So it's all about your confidence. How comfortable are you? The more you study, more you educate, you must be more and more relaxed, more and more comfortable, confidence. If not, maybe something wrong with your education. Definitely. Okay. So that means either you have selected a wrong field or you study in a wrong manner. Right? Wrong manner. So there are some context diagrams. Actually, context diagrams, the main context diagram we use in UML is uh, use case diagrams. Okay. But these context diagrams, so they are from structured diagram level as well. They have the DFDs, context diagrams, but context diagram is not really a standard UML diagram. Okay? But you can use high level use case diagram as a context diagram. That means one use case diagram showing all the high level functionalities. Okay. Basically, it's not 100% standard UML diagram. Okay. And so then the class diagrams, object diagrams. Remember, object diagram shows a snapshot for a scenario. So therefore, object diagrams are very rarely used. The class diagram is a general, in general, how the classes are related. Object diagrams are to explain a particular scenario and that kind of very special cases on. But both are static. So then use case diagram, the main diagram in requirement analysis, then state diagrams, sequence diagram, communication diagram, activity diagram, state diagram, component, deployment, composite structure diagram. New diagram introduced in UML2. Interaction overview diagram, another one introduced in UML2. Gives you the big picture. Timing diagram, because there are some interactions that triggered after some time, sort of a special case of a state diagram, but not really state diagram. Okay, something like this, going from one state to the other, but time oriented, not due to other event. Right. So the package diagram, and of course the profile diagram to extend your UML to add your own diagrams. And it's the extension mechanism, right? Lightweight extension mechanism. Because UML has predefined diagrams. So the profile diagram let you extend the standard UML and create your own additional features of models, such as for J2EE, .NET, okay, and so on. Right. So that is your topic 1. So then we move on to the topic 2. Software development, object-oriented software development method. Remember, early days we use waterfall approach. But one of the reason why object orientation is introduced is, uh, of course, one thing is it's better to better way of divide and conquer. But at the same time, a lot of emphasis on reusability, maintainability, handling, and the systems start becoming more and more complicated. So therefore, and also when we moved from 1990s towards 2000, and the society become more and more dynamic, competitive. We needed to develop fast at the same times, give early releases, right? So that is where a lot of emphasis on modeling, especially for object orientation. You need modeling, okay? Upfront modeling. Right. So initially we call it uh, rational unified process. So the unified process, which is a variation of iterative approach, but lot of emphasis on modeling, designing, architecture, okay, unified process. The unified process was introduced in latter part of 1990s. Remember the object-oriented programming languages like C++ came in latter part of 1980s, and then Java. Okay. So this is latter part of 1990s and early part of 2000 came the unified process as a special case of iterative development. So then came rapid software development, then came agile. So unified process to rapid development to agile. So remember, unified process has different phases, different workflows, and different roles. It's use case driven, architecture centric, iterative, and incremental. So a lot of emphasis on use case driven. So now when it comes to agile, how do you call a use case? Anyone? Now, in latter part of 1990s, during RUP, we call it use case, right? So then gradually we evolve into the agile development, right? Scrum-based development. In Scrum-based development, we don't call it use case, right? Of course, if you want, you can call it use case. Yes, when we modeling, we call it use case. But what is the other name we use? Anyone?
User stories?
Yes. Now we call it user story. Right? User story. Because remember, agile development is make it more casual, simple, right? So therefore, yes, when you draw a UML diagram, still we call it use case diagram. But we call that, okay, there's a new user story that we need to implement. So in this sprint, we are going to implement three user stories and so on. And you can see things are getting evolved. And a lot of emphasis on architect because architecture is very important when you develop an object-oriented system. Whenever we develop a complex system, we need architecture, right? Based on architecture, we design it and then we develop it. Okay. So different aspects of architecture, functional aspects, structural aspects, behavioral aspects, because at the end, your software must support all these. And there are different architectures, right? Client server architecture, peer-to-peer architecture. Client server also there are different variations, right? Distributed servers, two-tier, three-tier. That is why we have deployment diagrams, component diagrams to emphasize what is your architecture is, which component going to which nodes. Right? So as I told you, the rough process was iterative, incremental. Right? So what are the three views? Functional view, structural view, behavioral view. So this is how you look at the process. Okay? And also a bit of modeling. So what is the specific process that developed for object-oriented software development in 1990s and early 2000? Unified process. So special case of unified process is called what? Rational unified process. And now we have something called agile unified process, a variation adapted for agile development. So we have different phases. What are the phases? Inception, elaboration, construction, transition. So these are for the MCQs also, right? Inception, elaboration. So some iterations are more elaboration. Some iterations are now we are pretty much into construction. But in construction iterations also there are a bit of analysis modeling. But inception and iterations, the main focus is that. But still maybe bit of prototype development and so on. It's like a spiral. Okay? So then different activities, modeling activity, project management activity, analysis activity, design testing activity, okay, deployment activity, change management activity, environmental activity, that is it. We'll set up the environment. Initially, development environment. We need to set up the QA environment, the production environment. You can say environment is always, it's spread across because here development and QA environment, production environment. But business modeling and these things more into the early phases, less and less at the construction and transition. Likewise, you need to understand why this is like that. You can see testing gradually become more and more. Okay, because at the beginning you can't do testing, right? Still no system. Especially at the latter part, lot of testing because lot of production releases. Right? Inception, elaboration, construction, and transition. Right? These are the workflows, engineering workflows, business modeling, testing, deployment, configuration management, implementation or the development. So just you need to extract the big picture. So these are the additional phases like production phase, operations and support, right? And so on. And these are some production workflows, additional things. Okay, so this is mainly when your system is in the production. So these are some additional workflows, infrastructure, and operation and support workflows, production workflows. So those were not directly mentioned here, right? You can see here, those are not directly mentioned, but those are also additional workflows. That is why we say extension to unified process, right? Because it lacks concepts like budgeting, contract, staffing, maintenance. So that is why these additional workflows were introduced. And of course, it's very flexible. We can modify, we can add our own workflows. And these software development is an evolving field. So that is why there are variations like agile unified process, rational unified process, open unified process, and Eclipse unified process. So some variations used adapted by different developers, communities, and so on. Right? So just have that big picture, right? So right. So then we moved on to our third topic, computer-aided software engineering. Right? So remember, when we develop software, also we can use software, right? For diagrams like modeling, like UML, we can use diagrams. Integrated development environments like IntelliJ, test automation frameworks, right? Project management frameworks. What else? What else? Can someone tell me another possible case tool? I mentioned modeling and designing tools, integrated development environments, IDEs like uh, IntelliJ, testing frameworks like Selenium and so on, uh, JUnit, unit testing framework, project management case tools like MS Project. Can someone tell me one or two another type of case tools?
What about GitHub? GitHub.
Yeah, so that is another very important one. We covered that under web development also, right? So what category is that? How do you call it?
Repositories, distributed repositories.
Yeah, distributed repository. So configuration management tool, right? Configuration management tool. So likewise, there are different type of tools we can use. Okay, different type of tools. Development, design, testing, deployment. So there are deployment tools as well, like Kubernetes, deploying it to the cloud environments. But we mainly concentrated on modeling, analysis, and design tools for modeling. So these are the classification of case tools. Classic case tools and real case tools. So the classic case tools were mainly used for development, like compilers, debuggers. Those were used in 1980s and beyond. But these days, of course, we use these classic case tools, but now we have so many other case tools. Okay? And we subdivided. These are famous questions with exams, especially MCQs. We can subdivide case tools into three. What are those? Uppercase tool, lowercase tool, and integrated case tools. So how do you differentiate? How do you differentiate? Uppercase tools are used for early parts of the development, like planning, analysis, and design. For example, most of the UML diagrams are uppercase tools, obviously, right? Because it's mainly analysis and design. But if you take something like IntelliJ IDE, that is more implementation testing, lowercase tool. Okay. Lot of testing tools are lowercase tools, not lot of, almost all. So then we have integrated case tools that you can use it for throughout the development, from planning to maintenance, like Visual Studio and that kind of tools. Okay. Uppercase, lowercase, integrated case tools. And there are some tools are used repositories, central repositories, distributed repositories. Okay. Right. So integrated case tools helpful in all stages of system development lifecycle, not just early part or not just latter part. So when we use case tools, it improves productivity, consistency, promote teamwork. So likewise, now you must have that big picture. Maybe you should have a short note, mind map. What is your understanding about this subject? And of course, some of you guys will pass, some of you guys will fail, some of you guys will get A plus, some of you guys will get D. That is fine. I don't care. Right? So that is your result, right? So that is the level of your understanding. So I don't want every one of you getting A pluses. I know that everyone can't get A pluses for this subject, or everyone can't pass this subject also. But if you can pass, pass it. If you can't pass, fail it. Not everyone should pass exams. Those who have passed exams, there's no guarantee that you get a good job also, right? So if you are good enough, get a good job also later. If you are not good enough, see whether there are alternative paths for you. Remember, this is professional education, right? This is not grade 5, right? හැමෝම පාස් කරන්න එහෙම වුණාවක් නැහැ අපිටත් නැහැ. යුනිවර්සිටි එකත් එහෙම වුණාවක් නැහැ අපිටත් එහෙම වුණාවක් නැහැ. But try to get your best results also. It's good for your confidence, your career, your future. So these are the different eras of case tools. So early days we used to draw them. Pen, pencils, whiteboards. No standard those at that time. Right? So two things happens later. One is standardization, that is like UML. Second thing is more and more case tools. Computer software engineering, like Star UML, Agro UML, Rational Prose. Right? So what are the two things? Standardization of tool diagrams and more things like that, and also automation, use of more and more software. Okay. So this is the early days of manual case tools. Of course, this is data flow diagram which we use for structured programming, context diagram, data flow diagrams. ER diagrams. So at that time, people use either paper and pencil or the whiteboard and marker, or simple word processors, simple diagrammatic editors, and so on. But not a standard tool. No standardization of diagrams at that time. Okay. So now we have standardized tools. One is we have standard set of diagrams. We call them UML. At the same time, we use more and more computer-aided software engineering. So these are some tools used in the early days, okay? So this is another classification: diagrammatic tools, project management tools, documentation tools, configuration management tools, programming tools, quality assurance and testing tools, various classifications, okay? Right, all these, now you need to concentrate on exam also, right? Of course, I don't care exams much, but at the same time, right, you may be very talented, you have the very good attitude, but first of all, you need to win your Interview, job interview. How do you do that? Make sure that your CV has good results, say second class, upper, first class. So that grab the attention of the HR department and drive you to the interviews. But from that point onward, it's all your talent. Your exam results has nothing to do with that. From interviews to your career. But to get the interview, you need good results. Oh, good results will always help. Right. So remember, this plant UML is a very special type of UML tool where you can write it like in a text using annotations. Okay. It's very boring, but examiner, one of the examiner's favorite uh, tool, plant UML, because it's text-based tool, right? Text-based tool. Anyway, I have never seen people using this. One of the advantages, even a blind person can understand plant UML diagram because it's like a braille, because everything is textual, no visual thing. But it's terrible for others because we like our brain like uh, visual things. But this is a good way to uh, save your file so that it's sort of a interchangeable file format. Different software can render it in different manner, but rather than you look into one tool with one file format, now you have common file format. It's like XML for other places, okay? Right. Project management tools, documentation tools, configuration management tools, programming tools, right? Testing tools, right? JMeter load testing tool, JUnit, unit testing tool. Likewise, you need to have that understanding, okay? So best thing is prepare a short note by yourself. Okay? So the advantage is at the end, by the time you prepare your short note, actually you don't need the short note. That is the beauty of preparing a note. So you may think like, okay, I will use this note to study, but actually when you prepare the note, your studying is over. Now you have remembered. Okay. So that is called active studying. So you must get into the active learning. Active learning means you do something, not passively reading others' notes. No, you create your notes. So that is called active learning. When you do active learning, you remember, first of all, you understand and also you remember those. But if you do passive learning, it's very boring. It's very right. It will induce sleepiness. It's boring. It's stress because you try to read someone's note, maybe our note, UCSC note, but that is very boring stuff. Not a very productive thing. Right. So then we moved on to our third topic. Sorry, fourth topic, business process identification. Basically, model the requirements. Right. So the main diagram was use case diagram. So now you must be able to take a piece of paper and write down the stuff that you remember or you have understood about business process identification using use case model. Now, when we say use case diagrams, so that is the main tool. So what are the supplementary for use case diagrams? Anyone? So is it only use case diagrams we use? Because that is the big picture. Or can we use some other supplementary tools for addition to the use case diagrams?
Activity diagram.
Activity diagrams, yes, we can use it, but directly supplementary in the use case diagram.
Context diagram.
Context diagrams also we can use, but a context diagram is not a standard UML diagram. Oh, actually, the other things are also not standard. So what about there's supplementary to the use case diagram. How do you call it? Because last year there was a question, second paper question on that. They asked you to write that. After the use case, they asked you to first write the use case diagram, draw the use case diagram, then they ask you to prepare that. Supplementing your
Class,
sorry?
class diagram.
No, class diagram is not a supplementary into this one. Class diagram is the designing. So that is called use case descriptors or use case descriptions. Tabular format, right? Precondition, post-condition, use case ID, actors, main flow, alternative flow. Okay, so that is use case. So basically, you first prepare the use case diagrams, then as a supplementary thing, you prepare use case descriptions. So those are the two main things. Okay. You can see use case diagram, then use case description. So you need to have that big picture. Right. So remember, use case diagram is the main modeling diagram for requirements. So it's a documentation. Remember, what are the requirement analysis subtasks? Gather requirements, analyze requirements, model requirements, document requirements, verify requirements. So these 5 tasks can be done with the help of use case diagrams and use case descriptions and any other supplementary diagrams like activity diagrams and so on. Right. So it's a very simple, high level way of documenting your requirements. So in use case modeling, we are interested what are the business events, who initiated the event or the actors, how the system respond to those events and so on. So you have the system boundary, use cases and actors. And there can be some relationship between use cases like includes, extends, depends, inheritance or generalization. So this is the communication between actor and use case. So this arrow denote it's from actor to use case. Sometimes it is use case to actor. Sometimes no arrow means actor inputs something and actor gets something like a receipt or something. So remember, your actor can be human or another system. But both you just represent in sticky figure. Okay? And it must be placed outside the boundary. If you show the boundary, sometimes we don't show the boundary, but if you show the boundary, actor must be outside the boundary. And we can categorize actors into 4 main types. Primary business actor, primary system actor, external server actor, external receive actor, server receiver. So the primary business actors. So those are the main business actors like employee, customer. So the primary system actor is the one that directly interfaces with the system. This is benefit from the use case. So these actors get the benefit. These actors directly interact. Maybe the customer is the primary business actor. Maybe the salesperson or the receptionist is the primary system actor. So primary system actors can do things on behalf of the primary business actors. Sometimes your primary business sector will directly interact with the system, like online money transfer, right? Banking system. So then your primary business sector is directly interacting with the system. But if you go to the counter and deposit money, so then your primary business sector is not interfering with the system. That counter clerk or the counter uh, executive will be the primary system actor. Okay. So then you can have external serve actors, external receive actors. Okay. So server provides something, service, whereas receivers, usually they get notifications and so on. So then you can have actor generalization. A particular actor can be a special case of a general actor. Like customer can be a platinum customer, gold customer. Okay. So then if a super actor can do something, so that can be done by inherited to the sub actors as well. But whatever the sub actor can do is not in can be done by the super actor because it's inherent top to bottom. So then the use case. Remember, use case must be very short description of the functionality, just maybe few words, and you must have a verb, make reservation, make payment. Okay. And there's a communication relationship between the actor and use case. And you can show the direction and also you can show the multiplicity. Multiplicity is pretty much optional, right? Very rarely we show, but if you want, you can show it. But definitely we are interested in directions. Actor to the use case or use case to the actor or both. Both means no arrow. So then the relationships, extend relationship, include relationship. Can someone tell me the main difference between extend relationship and include relationship? Both are between use cases. දැන් මේ ඔළුවේ තියෙන්න ඕනේ ඉතින් හරි. එක්සෑම් එකට සතියකට කලින් ඔළුවේ තියා ගන්නවා කියන්නේ අර බොරුවට විභාගයට පාඩම් කරන කට්ටිය. ඒගොල්ලන්ට ඊට පහුවෙන්ද ඔක්කොම ෆියුස් යනවා. දැන් ඔළුවේ තියනවා කියන්නේ so it's an investment for your career, your life. What is the main difference? Yes.
Include means if action happens, it triggers another action.
Okay, then what about extends?
Extend means it's exceptional.
Exception.
It sometimes happen.
Yeah.
It sometimes happens.
Yeah, sometimes happens is correct. Or if you put it into a little bit more formal words, optional, right? So extends means when A happens, optionally B happens. So then there's an extends relationship. Includes means always happen. Whenever A happens, B happens, then it is includes. When A happens, sometimes B happen. So then it is extension. And remember the arrow is in two different directions. In extend relation, right, the arrow is towards the main use case. So when you place new order, sometimes you refer to the catalog or the actor will refer to catalog. So this is your main use case. So the arrow is towards the use case and it's a dotted arrow, dash arrow. But when it comes to include, it's from your main use case to the sub use case. That means whenever change employee details, find employee details must happen because without finding you can't change. So this is your main use case. So whenever this happens, You can see it's going towards the include use case. And also you can have the stereotype include and here stereotype extends. Okay. So these things are very, very important. Because for the exam, the most important diagrams are the use case diagrams and class diagrams. Okay, for the exam, second paper. Right. So then depends on. So that means this use case can happen if this has already happened because it depends on that. Depends on that. Okay. So make deposit can happen if already the bank account is established. Okay. And make a withdrawal can happen only if make a deposit is already done because without otherwise you don't have money. So very rarely we show depends on relationships because there are so many dependencies in systems. But if it is very important to show, yes, show it. Otherwise, don't show it. But again, you can see that this is your main use case. This use case depends on this one. In this case, this is your main use case, our main focus. But this can be done only if this has happened. Okay, depends on this use case. Depends on this, and this use case. Sorry, this use case depends on this. Right. So then the
So,
generalization. Remember, we look at the actor
so
generalization. Sorry,
what is the major difference between optional and exceptional?
optional and exceptional. I think the word exceptional is not the general word we use. Right. Optional means when A happens, optionally B can happen. Right. For example, when you have your lunch, sometimes optionally you take a drink like soft drink. So that is optional. Some people will get the drink while having the lunch, others will not. But maybe the includes relationship is right always. So whenever you have your lunch, say if it is rice and curry or something, you wash your hands. So that is include. So whenever you do this, you do that. So that is called includes. So other one is extensive. The better word is not exceptional, optional. Right? Optional, not exceptional. So when A happens, optionally B can happen. Okay? B can happen. So that is extends. Always, whenever A happens, B happens, that is includes. Right? So this is actor generalization. Right? So similarly, you can have generalization of use cases. Okay. So withdraw cash is a special case of a ATM transaction. Okay. So that is a different thing. So you can have extend, include, and also the third type is between use cases, you can have generalization. So this is the general use case. This is the special. You can have multiple special use cases as well. So your use case diagram, depending on the scenarios, may have some of these relationships, and it may involve multiple actors and so on. So when you draw use case, model use case, it's in a way two people will come up with two different use cases because it's pretty much subjective thing, right? But if those two are experienced software developers, most of the time there will be a lot of similarities. Right? So that of course you can get it with your maturity, experience. Right. So this is a use case description because use case is very simple, right? Sometimes you just draw one use case diagram for the entire system, high level use case diagram, or you can go for little bit detailed use case diagrams. Say payment module, one use case diagram, order module, another use case diagram. customer module, another use case diagram. But for a small systems, for the entire system also, you can just create one use case diagram. Okay. Anyway, whatever the way, your use case diagram has just a simple description of the use case. It doesn't show you the exact business logic, business flows, right? Main use cases, exceptional situations. That is where you can write a use case description. It's a tabular format. We have the use case name, use case ID, maybe use case priority. Who are the primary actors, secondary actors, preconditions, post conditions, main flow, alternative flows. Okay.
So we must draw according to this format, or
Yeah,
is there?
yeah. So this is the format.
Okay.
So there are slightly different formats, but in general, this should be the format in general, right? Like use case name, use case ID, use case priority, uh, primary actors, sometimes even secondary actors. Sometimes we even show stakeholders and so on. Those are optional, but definitely the precondition, post conditions, right? Normal flow and exceptional alternative flows. So this is the structure. You can see other primary business actors, other actors. Here they just mentioned just primary actors. And here there's use case type also. Anyway, those are little bit optional things. Other interested stakeholders, description. Here, this is the better approach actually. You have the normal flows, alternative flows, and so on. Okay. So last year also there was a question where you are supposed to write the use case description, or sometimes you call it use case narrative. Okay. You can see sometimes we use the word use case narrative. Same thing, right? Slightly different name, use case description, use case narrative. So I think this is the best detailed one. Use case name, use case ID, priority, sometimes even source, who came up with this use case or the user story. You can have use case type, primary actors, other participating actors, other stakeholders, the description you can have. So then you can have the main flow, alternative flow, the exceptional flows, precondition, post condition you can have addition to this. Okay. You can see post condition, precondition, sometimes even something like trigger. Okay. So this is your main process, typical course of events, alternative causes, or the exceptional causes. Slightly different wording can be used by different people, but in general, follow the structure. Right. So that is very important. So this slide is very, very important, this note, because every year, guaranteed, there's a use case diagram related question. That is your first question is always use case related diagram related question. Right. So then we moved on to activity diagrams. So that is very easy, right? Just like a flow diagram. But you need to pay attention to certain things. So activity diagram shows the flow of business activities or one activity, or mostly for one activity we draw one activity diagram. Okay. Or it can be for a use case. Okay. It's like a the flow diagram but it's not really a flow diagram, okay? So you have a set of activities represented by rectangular shape but rounded transitions. මේවත් අහනවා exam එකේ. Second paper එකේ අහලා තියෙනවා ගිය පාරක්. මොකක් හරි diagram එකක මේ වෙන වෙනම මේව මොනවද අඳින්න කියලා. Decision points. So says if it is check payment, do these steps. Cash payment, do that other, right? Other part. Decision points. So then there will be merge point because after doing the payment, maybe dispatch. Dispatch may be common, whether you do check payment or cash payment. Merge points. Synchronization bars are used to show parallel activities. Okay, parallel activities. So starting and then merging. So join is the end of the parallel activity. Synchronization bar shows the start of the set of parallel activities. Right? So this is pretty much parallel activity start. Sometimes we call it fork. Right? So synchronization bar can be a join or fork. So this is starting. Right? This is end of parallel activities and now you are into one activity. But this can happen only when all these are done. You can see fork node, join node. So this activity diagram is from left to right, but most of the time we draw activity diagram from top to bottom. So these are parallel activities. This is a decision point. Your flow can go either this way or that way. So you can optionally have swim lanes. So swim lanes can be shown for who do this or who does it, who does these activities. Maybe the customer swim lane has those activities. Maybe the sales executive, another swim lane, or maybe it's client versus server. Okay. Sometimes even the user operator versus machine, swim lanes. So these are the swim lanes. It gets a little bit distorted, but swim lane has a purpose. Right, so what are the new concepts included in UML2 for the activity diagrams? The passage of time. Right, that means it goes from this activity to that activity maybe after 2 minutes automatically. Then the exceptional activities you can show using this notation rather than this notation, like erroneous situations and so on. And also the sub-activity indicator. So that means it's linked into another sub-activity diagram. Right, so that is activity diagram. Now we have the small topics, okay? So then we moved on to class diagrams and package diagrams. Class diagrams and package diagrams. Right, so we'll take a break. After the break, we'll look at these things and do. Today we are going to do the 2022 4 paper. Then maybe Sunday class we can finish it. Right, so that means by end of this week, object-oriented is over. Okay, right. So other than the use case diagrams, the second most important type of diagram is class diagram. Because if you look at the second papers, you will find that every year there's a question on use case diagram, then class diagram, and third, it's sequence diagram. So those are the three major diagrams: use case, class, sequence. Okay. Of course, other diagrams also they ask, but these three the most important. Okay. Right. So remember, class diagrams is a structured diagram. use case diagram is a dynamic diagram. Because class diagram is the major diagram for design. Right? It shows how the classes are, what are the classes, and how they are related. Okay. So what are the things that you show in class diagram? Can you list down 5 things that you show in class diagrams? 5 or whatever. Obviously classes. What else? What else?
System.
Sorry?
System.
System is not shown in class diagram.
Relationships.
It's relationships. What else? What about interfaces? And what are the type of relationships we show? Anyone? What are the type of relationship we can show in class diagram? So this is your study.
Inheritance.
Yes, inheritance. What else?
Association.
It's association. Two more. Actually, there are 3 more. Realization. That is between a class and interface. The class can realize, so implements. So then composition and aggregation. So remember this and this diamond shaded, diamond without shade. Shaded diamond is composition. Without shading, aggregation. So now you must be really comfortable with these concepts and how these concepts are interrelated. Okay. Right. Inside class, what are the 2 things we model?
Attributes and behaviors.
Group and
Attributes
behavior.
yeah, attributes and behaviors. Okay. So now, because you guys need to talk now, right? Can someone explain me what is the difference between class and interface? So that is good for your confidence. These are the interview questions. If you go for a job interview, internship interview, what is the difference between class and interface? Or briefly explain class and interface. You can't take too much of time. Just 1 or 2 sentences.
Class is a model that represents a set of similar objects,
Okay.
but interface is a is interface is an agreement. If we need to use that, we have to implement those behaviors.
So yeah, definitely you give me the correct answer, but your answer is missing 1 word. If you use that word, your explanation could have been much easier when you explain interface. Yes, you use the word agreement.
Class is for inheritance and interface for polymorphism.
Yeah, so that is also correct. But class can also be used for polymorphism, right? Remember, my dog can act like
Yes.
animal, so that is inheritance, right? But at the same time, polymorphism.
Class is a interface is a abstract model.
Yeah. So the word you should have used is role. Interface represents a role a class can or set of classes can show. Okay. For example, animal is supertype, dog is subtype, Pet is an interface. So pet is a role dog can play. So therefore we can say dog implements pet interface. So pet is a role. Right? Yeah. So in otherwise you can say it's agreement, but that is more technical word. But if you want to explain it at high level, simple level, you can say interface is a role class can play. Okay, an object can play. A class can implement any number of interfaces depending on whether that particular class want to play that role. So okay. So inheritance is for both. So the inherent relationship is for both inheritance and polymorphism. Right? So dog inherit from animal, so that means inheritance. Animals features are inherited to dog. At the same time, when animal is expected, you can say the dog. That is polymorphism. But interface is 100% for polymorphism, not for inheritance. So why do we say that interface is not for inheritance? Anyone? It's only for interface, polymorphism.
So can you repeat the question, please?
Now, class can be for both inheritance and polymorphism. But interface is only for polymorphism, not for inheritance. If you agree, explain. Otherwise, you can say, I don't agree with that. So why do we say that class is for both, can be for both inheritance and polymorphism, whereas interface is for polymorphism, not for inheritance?
Because class is for inheritance, so it automatically implement the polymorphism, but interface is too abstract, so we can't inherit, we can only implement, so it's
What do
only
you mean
for
by too
polymorphism.
abstract?
That means we can't create object from that.
Okay, just because you can't create object doesn't mean that it's not inheritance, right? That's a different story. For inheritance, you don't need the super type creating objects or not, right? It doesn't matter, right? So your answer is there, but I just double check whether you have that confidence. What is your confidence level about that answer? So when
In inheritance,
yeah,
when we create a behavior, we won't usually say how it works.
yes, so
When we
that is
implement
exactly I
it
was looking at. Yes, so when you inherit the behavior because the super type has implemented the behavior. So that you don't need to, unless you override it, you get that behavior. But in interfaces, we don't implement the behavior. So therefore, you can't you don't inherit, because if you inherit, that functionality must be in the super type. So therefore, here there's no inheritance, right? Because you to inherit, the super type must have implemented the functionality, but interfaces can't have single implemented functionality. All your methods must be just the signatures, right? If so, that is why I say, that is why you said that interface is too abstract. Yes, interface is too abstract, but then you need to explain why it is not not inheritance, because it's too abstract. Then you need to explain that none of the methods have implementation, so therefore no inheritance of implementation. So then it's for polymorphism because it's a contract. The contract is, if you implement this interface or realize this interface, you must implement all these methods. Okay, so it's a contract, right? Saying that it's, yes, this object can play that role. Why? You must have, this class has implemented all these methods in that interface. So therefore, safely, when you're expecting that interface, I can send this object because this object has implemented this interface. So that is a contract. Okay. Right. So this is the most important question I would like to ask. And I know that very small percentage of students has an answer for this question. Uh, Now, what is mean by association relationship? What it means in object-oriented context? How do you explain it when it comes to programming? So what is mean by A is associated with B? If in a class diagram, if you see that A is associated with B like this, what does it mean? That is my question, because that is why we draw class diagrams, right? So you must be able to read and understand a class diagram. Then you must be able to draw class diagrams. It's drawing, it's not drawing, it's modeling, right? This is not drawing a picture, painting. So
That means class A calling all the behaviors of class B.
yeah, if you put it to a little bit better answer, can a class call behaviors of another class?
If we call the behavior of A,
Objects of that class.
Yeah, object of. So if A is associated with B, that means object of a class can call behavior of a object of a B class. Behavior or behaviors of object of A class can message object of B class. One or more. So it depends on whether it's one to many, one to one, and so on. Okay, many to many, and so on. So that means if it is one to many, association, unidirectional. So that means object of one class can call behaviors of many objects of B class. If it is one to one, object of class A can call behaviors of object of class B. If it is bidirectional, that means object of class A can call behaviors of object of class B, as well as object of class B can call behaviors of object of class A. Now, when it comes to implementation, how do you make that? So if you have two classes like this, when you implement these A and B class, how do you make sure that this, say this one to one? How do you code it? Because otherwise, what is the use of your class diagram if you can't? Now, if you have A and B like this, so that means you have class A, and then you have class B extends class A. Right? So that is inheritance. Now, similarly, how do you implement A and B? If between A and B, we have one-to-one unidirectional association. What is the structure of class A? What is the structure of class B? Or you need to explain the structure of A and B. And how do you implement this A associate with B unidirectional?
we will create a B object inside the class A.
Yes, either you need to create a object inside class A, or so that means inside class A, you have say B, say simple B equal new B, something like that. Okay, is that what you mean?
Yes, sir.
Yeah, it's an instance variable, right? You, rather than saying create object inside class B, you can say put it little bit more formally. In your class A, there's an instance variable of class B, because that instance is your supporting object for A. Every A object has a B object, supporting B object. Either you can hard-codedly create this object, or what is the other option? You have instance variable, but you don't create the object. Then what will happen? Then what will happen? This approach is the most widely used approach. So you have the instance variable, but you have not created the object. So then first you create a B object when you are using this. say B equal new B. Then you create your A object, A equal new A. Then there must be a setter method, set B or something. So then you can say A dot set B, your B object. So by that time you can customize your B object setting attributes and so on. So that is more flexible. Okay, that is most flexible. Where the user can create the B object according to the requirements and set it to the A object. So then now when we have association relationship like this, what is the result in sequence diagram? Now in sequence diagram, when you send a message to A, right, say do A or something, so then A can send a message to B. Why? Because A has a B object, which you have either created or the user has set it. Now, as part of doing this A task, uh, A object can call, say, do B task. Then, when it returns, maybe you do some more things and you return. That is the idea. So, likewise, you must be able to map it from class diagram to sequence diagram and also coding. So, if you have that total understanding, so that means you are, and of course, if you have that IQ, attitude, right, logical thinking, so then you are ready for a software engineering career. It doesn't mean that just because you know these things, you must be a software engineer, but you are ready, right? You are ready. So you must ready for something, right? Maybe. When you are about 20, 22, you must be ready to do something, maybe engineering, medicine, accounting, marketing, I don't know. Care, whatever you do, you must be ready for something, right? You must be ready for something so that you earn money, not a burden to your family, your parents. This is how you become ready for a career in software engineering. Maybe you are ready for multiple careers. Then you decide, okay, yes, I'm ready for career A, career B, but I want to get into career A, not B, because I prefer career A, whatever, right? But if you are not ready for anything, so that means you are a burden to your family, your society. You have not fulfilled your objectives in professional education. Right. Right. So we are interested in classes. So what are we interested in classes? Attributes and behaviors. Another name for behavior is a service. Your attribute will be either instance variable or class variable. Your behavior will be either instance method or class method. So if you study it in a proper way, rather than like a parrot. Right. So the association is the most important thing. So association means A associated with B means object of A can call behavior of object of B. Get the support of that as doing part of doing your task. So it can have a direction, it can have multiplicity. Direction can be unidirectional or bidirectional. Multiplicity can be one to one, one to many, many to many. So this is unidirectional association. So these are the two special cases. This is aggregation, this is composition. Those are special type of associations. Still, those are associations, but special type of association. It's a stronger aggregation is a stronger form of association, and composition is an even stronger form of aggregation. That is why we share it. So composition is a whole part, but part is not tightly controlled by whole. That means part has independent existence. But if the part is 100% controlled by whole, and 100% part cannot exist without whole at all, but here part can exist without whole as well. So then if the part is 100% under the control of whole and part has no life without the whole, then it's composition. So I told you faculty cannot exist without university. So therefore, faculty and university, we have composition. Right? A ward cannot exist without a hospital. Those are composition. But aggregation means it's still whole part, but part is not 100% under the control of the whole. Or part can exist even without whole as well. So engine can exist without aircraft. But in general, yes, engine is inside the aircraft. And also association can have not only the multiplicity and direction or navigability, it can have role names. So usually if you have the role names, you don't need to give the association name. But sometimes you don't give association name or role names neither. But usually you don't give both. So in this association, the company play the role of employer, person play the role of employee. So these are the multiplicity indicators. So when we say star, it means zero, actually zero or more. Right? So star means zero or more. But if it is one or more, that is mandatory. You need to say one dot dot star, right? Star or zero dot dot star means zero or more. This is zero or one. This is exactly one. Or you can have specified number, 5 to 8. So there can be reflexive association. Yes, of course. Class associated with another same class. Right? Now you must be able to give some examples. Right? So I think the example I gave you is something like social media like Facebook. A member can have a friendship with another member as reflexive association. And so then the inheritance and realization and so on. Right. So it's very important that to identify your classes or the first objects, of course, to represent all the objects of same type you have class. Okay, class. So how do you identify these objects or classes? You can analyze your use case descriptions and user stories and so on. That is called textual analysis. So usually some nouns will be candidate for classes. Of course, some other nouns will be the attributes of a class. Right? So your description will say customer, payment, order. So of course you can do some brainstorming as a team, identify what are the classes, right? What are the what are the inheritance relationship, what are the association relationship in our system. So these things are usually done as a team. Team. So therefore, don't worry if you go for software engineering or job, all of a sudden you are given to design a system. No, first of all, you will be assigned some bugs. That is how I absorb into software engineering. So when I first joined my first job, I can remember for about 3 months, only I got some bug fixing. Of course, at first I got a training about 1 month, familiarized with the domain. So there I learned even accounting concept because I had never done accounting at serious level because I was assigned to an accounting project or the accounting module of a ERP. So then how can I fix bugs or start developing things if I don't know the or if at least if I don't have good revision on accounting concepts. So then the technology stack like Oracle database. So that is how you will be absorbed. Right? You will be absorbed. But gradually you will start playing more active role. More active role. So don't think that it's always coding, coding, coding. No. And when you join a new project, say first job, all the others are more experienced than you. So help is always there. For example, if you can't fix the bug, you are assigned to say you are assigned a bug, you can give it to someone else. So they will get it because they have better understanding about they are more experienced, right? So likewise, it's you are not isolated, right? It is not you are intimidated or no. It's a teamwork. And gradually, when you become more and more senior, when new guys come, you help them. So that is how you grow your career as well. Then you play leadership role. Okay. Like brainstorming can be used to identify classes, objects. And of course, there are common objects for different domains that with your experience, you know that if it is banking system, so these are the common objects. If it is airline reservations, you know what are the common objects with your experience. So those are the clues for you to identify objects. And there are some patterns. So CRC card is a very old concept, but examiners have repeatedly asked about CRC cards. This is a very old concept. I have never seen software developers using this concept, but for the exam, yes. Class responsibility collaboration cards. It's another way of uh, identifying classes and doing some basic documentation. Right? So it's a card actually, where you can document for a given class what is the class, what are the responsibilities of the class, and to with which class this class can collaborate or this class need to collaborate. So those things will be later associations. CRC, class responsibility collaboration. So what is the class? Bank account. What are the responsibilities? Maintaining balance. Collaborators, it says bank or maybe customer, bank, payments, and so on. Responsibilities, collaborators, and of course the class. So then you can have the attributes and behaviors of the class. Attributes and behaviors of the class and other relationships and so on. Okay. Aggregations, compositions, CRC card. Anyway, this is a very old concept, but for exams, just have a look at it. Okay. Right. So remember, when it comes to classes, you can use some stereotypes to identify or categorize your classes. What are the three type of classes? Uh, Domain classes, boundary classes, okay, domain no entity classes, boundary classes, domain no entity classes, and control classes. So boundary classes are the interfaces. Use interface or system interface. Use interface means it can be a form, report, boundary class. Entities are the major domain classes like payment, customer, order. Control classes will control different business flows, like manage payment, right? Manage orders. So those are the control classes. In MVC architecture, these are the controllers. In a MVC, entity will be the model. Boundary will be the views. Model, view, control. But in reality, this boundary can be not only a view, it can be a system interface as well, like a web service interface. But MVC is specific concept for the web developer. But in class diagram, very rarely you show these boundary or control or entity, right? Very rarely. But theoretically, yes, you can show these classes like that. Some entity classes, control classes. So you must be able to identify classes, inheritance, associations, compositions, aggregations, and so on. You need bit of experience. Bit of experience. So this experience you can't get when exam is 1 week away. So that is firefighting. එක්සෑම් එකට සතියකට කලින් මට කවදා සබ්ජෙක්ට් ඉගෙන ගන්න බෑ. ලොං ටර්ම් ඒක අපි කියන්නේ එක්සෑම් එකට සතියක කලින් මොන හරි පාඩම් කරනවා නම් ස්ටඩි කරනවා නම් ඒ එක්සෑම් එකට. ඒක ඇතුලේ ඔයාගේ ලොං ටර්ම් කැරියර් එකට ජීවිතේට කිසිම අලුත් දෙයක් එකතු වෙන්නේ නැහැ. ඒක අපි කියන්නේ එක්සෑම් එකකට සතියකට කලින් කරන ස්ටඩීස් වැඩක් නැත. දැන් කරන ස්ටඩීස් වල තමයි මොකක් හරි ලොං ටර්ම් ප්‍රතිඵලයක් තියෙන්නේ. එක්සෑම් එකට කලින් සතිය කරන ස්ටඩීස් තනිකර එක්සෑම් එක පාස් වෙන්න දාන්න දහන් ගැටයක්. ඒක ඇතුලේ අවංක අරමුණක් මුකුත් නැහැ. ඒක ඇතුලේ තියෙන තනිකර තක්කඩිකම විභාගේ පාස් කර ගැනීම. සහතිකයක් ගැනීම. Right, so then remember we can have the package diagrams. So package is a concept that we use to aggregate the related classes. Say payment related classes, we can take it to the payment package. Order related classes, order package. So remember we discussed packages in semester 1 programming also. So package help organizing your classes, related classes into packages or basically folders. And also it gives you an opportunity to mechanism for access controlling. Remember the access controlling, you have the private package access control, protected, public. So package means that can be accessed by your package members. Public means not only your package, from any other package, a class can access your class. And so on, right? So package diagrams shows how packages are related. So this is how you represent a package, order package. So it can have set of package classes, custom order utilities, and so on. Okay. And package diagram can have dependency. This package depends on this package. So that means this package refer to some classes, interfaces of this package. So that is one type. And also one package can inherit to another package. That means subclasses are in the other package. But mainly it is dependency. Right. So that is class diagram and package diagram. So then we look at behavioral diagrams, so the interaction diagrams. So the main diagram was sequence diagram. Sequence diagram. So sequence diagram shows for a particular scenario, use case, what are the passing messages. So your sequence diagram can have actor. Actor can be human or system. Okay. Actor can be represented like this or even like this. So then your class or object. So this is your object name, class name. Or you can just give the class name. Or sometimes just the object name. It's up to you. But best case is give at least the class name. Or both class name and some object name. But most of the time class name is enough. So then the lifeline. So object creation time, object destruction time. So this is your active time period for that object. Remember, time goes from top to bottom into sequence diagram. So this is your active period of that object. Then messaging. Message and return value. Return value is dotted. Okay. Arrow. Your message can have guard condition. So if that condition is satisfied, only this message is sent or the method call is done. Message is sent means method call of the other object. So optionally you can show destruction of the object, but it's optional. And also you can have frames to show some documentations, SD frames, remember alternative ALT frames, PAR frames. ඒ ඔක්කොම කරලා තියෙන්නේ, ah. Right. So you can see this is just the, remember after the colon you have class name. So this is borrower class name. Most of the time we just give the class name. Or you can say borrower 1 from borrower class. Or account number this from this class. But very rarely we give the object names. Most of the time class name is good enough. The message is going from borrower class to the borrowed copy class. Or object of borrower class call get audio details behavior of object of a borrowed copy. So this is possible if there's an association between borrower class and borrowed copy class, right? Association. So that the moment you see this, you must know that there's a, in the class diagram, there must be something like this. This is borrower, this is borrowed copy. That is why, that means in the implementation, borrower class has an instance variable of borrowed copy class. Object created to object is injected. Set. Right. Any questions? ඔයගොල්ලන්ට තේරෙනවද මේ මම හැමදෙස්සෙම ඔයාලට big picture පෙන්නන්නේ. හරි. class diagram එක relate කරනවා generate වෙන code එකට. class diagram එක relate කරනවා sequence diagram එකට. ඔය big picture එක පේන්නේ නැහැ කියන්නේ. හරි. So that means you don't have the mindset of an engineer. Maybe you have the mindset of a technician. මං කිය garage එකේ බාසුන් නැහැ තමයි overall responsibility එක. සමහරව හැමදාම මලකට උරෝර ඉන්න. එයාට බෑ overall responsibility ගන්න. හැබැයි එයාට කිව්වොත් පොඩි කෑල්ලක් බලන්න කියලා බලනවා. So the person who take the big responsibility, big picture is the top person. That is engineer, that is accountant, that is doctor, right? That is the CEO of the company who can look at the big picture, who has that big heart. Otherwise, you need to look for small job where you will be just a small nut or bolt of the system. So this is the reality. Or else you take a lot of responsibilities. So usually your starting point will be a boundary class because most of the time it is UI. Right? You actor, then boundary objects would be. Afterwards, you will have maybe control class and then entity classes, or directly entity classes if you don't strictly follow MVC But usually it will be boundary class to the controller class to the entity classes or domain classes. So this is a high level sequence diagram. It's like context diagram. So it's between your system and possible user or one user or whatever. But this is just very special case. This shows overall functionalities like use case diagram. But most of the time we draw this, maybe this is good for requirement analysis. But in designing and development, we draw one use case diagram for one business flow, one activity. That means you can have multiple use case sequence diagrams. Okay. So these are some examples. See. So messages you can number it so that it's easier to read. And remember, you read it from top to bottom. This message is sent to this loading form boundary class. Loading form boundary class send message to the member. That means most probably domain or entity class. So then another message is sent to interaction between the user and the UI. Another message passing. So after this message is written again, this guy call another message and so on. Okay. And so these examples you need to look at. And also how to convert that model design into code, because otherwise useless, right? And you can have self-messaging, non-recursive versus self-messaging recursive. This is a very famous area for the exams. So you can self-message non-recursive, self-message recursive. What is the difference between self-message recursive versus self-message non-recursive? Anyone who has done your studies, maybe the study කරලා තියෙන කෙනෙක් කියන්න බෑ. You need to explain the difference between these two.
Recursive message means a behavior call the same behavior. That means the function that calls the same function.
Is it like this? So there's a message called do way to a particular object. Say A object, and A object call do way. Now, is this recursive or non-recursive?
Recursive.
This is recursive. So the non-recursive self-message means, say, this do way is called, but A call may be do way util or something, which is not the same method, but it's that behavior is also with your class or your object. Say you call do A util. Okay. That is non-recursive self-message. So likewise, you must have very crystal clear understanding. Okay. Another method belonging to the same object. So that is non-recursive. So recursive, you call the same method. So what is the reason a method object calling recursively calling it the same method? What can be the possible reason? So one possible reason is maybe it's divide and conquer approach, right? Recursive calls are used for divide and conquer, like sorting algorithm. Okay. But sometimes that recursive call can be due to some business logic as well. So this is recursive call. But this is again recursive call.
Sir,
Yes.
does recursive always divide and conquer?
Not really. Most of the time divide and conquer, but sometimes it can be due to business nature, business rules or whatever.
Can you give me example?
For examples, I think there was an example like that in your, I think this type, our note or this note, say when there's a make reservation, right? So it call make reservation again because maybe check if the first reservation is not available, maybe you try another room, right? So you keep checking the reservation, or maybe say you need to make reservation, but not one room, maybe 10 rooms. So then you call make reservation 10 times for 10 available rooms. So that is not actually divide and conquer. It's part of the business process. But you know that we can have the divide and conquer as well, like sorting algorithm, say merge sort, you break it into two half and apply the merge sort. And then to that again you break it into two half and apply the merge sort until you get into just two data elements in your array, sub array. Right. So that is not business rule, it's part of your strategy, solution strategy. Okay. So this one is calculating factorial. This is a technical divide and conquer. You can see calculate factorial. So you are supposed to calculate factorial of 10. Now you calculate factorial of 9, 10, 8, 7, 5, 4, 3. And in the return trip, you have find the factorial of 10. Now you can return it. Okay. So this is recursive. If this is message, this is also message. And this is non-recursive. Maybe you are calling some other methods of the same object or same class. So then you can have constraint in your message. If this condition is satisfied, only this message is sent. Otherwise, this message is not sent. Okay. So then frames. So frames are to provide additional details about or part of your, you can mark part of your sequence diagram and provide additional details. One is ALT frames. So that is alternative. Either this will happen or this will happen. Depending on the, if they approved, this message is sent. Not approved, this message is sent. ALT. Alternative responses. You don't get both responses. So both message call. One of those, depending on the condition. Right? So that is called ALT. So then you can have OPT. Optionally, it can happen. Optionally. Let's see whether we have option. This is also ALT. Condition 1, condition 2, else. If condition 1 is satisfied, this. If condition 2 is satisfied, this. If none of these conditions are satisfied, this message passes. You can see if part, else part. Either these message passing happen or these message passing happen depending on the condition. So this is a loop frame. So that means this message passing happens in a loop, iteratively, maybe 5 times or until a condition is satisfied. So this is opt. The interaction operator op designates a choice of behavior where either the sole operand happens or nothing happens. So then you can have break, break. You know what is the meaning of break in Java and other programming language, right? Breakout. And you can have parallel operations, parallel message, that is asynchronous message passing. Right? So critical segments and so on. Okay. So those are all. SD means just standard. Maybe you just won't label it or something. This is parallel. So this is critical. So then you can have ref. So ref means this part is there is a message passing inside there, but because it's complicated thing, because you want to give this as a big picture, you have put it into a separate sequence diagram. If it is a tool, when you click here, it will open the sequence diagram showing the message interactions here. That is called ref. That means you refer to another sequence diagram. Part of your sequence diagram is referring to another sequence diagram. So you go there and check what happens here. Okay. Right. So that is called sequence diagram. So then you can have communication diagram. Or sometimes we call it collaborative diagram. So the only difference is sequence diagram has more complex features like these frames and time goes top to bottom and so on. Okay. But in communication diagram, it's very simple. You have the class or object and messages. And messages you need to read using numbering. Okay. So therefore, it looks much simpler. Right? It looks much simpler, but at the same time, it can be a little bit messy. But even someone who is not very technical can easily understand communication diagram, though it looks a little bit messy. So therefore, this is much better for something like communication with get some clarification with the customer and so on, because this is easier for non-technical person to understand. Here, there's nothing called time going top to bottom. Therefore, we 100% depends on numbering to understand how the message passing happens. So these are different elements in sequence diagrams and sorry, communication diagram. Message, synchronous message. So these are very small but very important, right? So you can say synchronous message, solid arrowhead, asynchronous message, open arrowhead, return message, dotted. Right? So object creations, object destruction. Object creation means when you create a object, so you need to create a B object and then call the behavior, right? Destruction means that you no longer need that object's help because you got the result. So that means it's now candidate for garbage collection for that object. And these are especially when you communicate with මේවත් අහලා තියෙන exam එක MCQ වලට තමයි MCQ කරද්දී මේ question අහුවේ යා. When you interact with outside of your system, outside systems, right? So that means this is your system. You are communicating with another system. So then you can have these found messages and lost messages. So found message means you get a message from outside. The sender of the message is outside the scope of the interaction. So then you call it found message. Maybe you got a message to your message queue. And message queues can අපි කතා කරන enterprise application development subject එකේ semester 4 වල. කොහොමද message queue එකට දාන්නේ? එතකොට message queue එකෙන් තමයි system එක ගන්න. So that's a found message. So lost message means you send a message to another system, but it never reach the destination system. System අතර යනකොට message lost වෙන්න පුළුවන්. Time out වෙනවා, internet connectivity drop වෙලා හරි වගේ. Okay. Right. So then the state machines අපි ඒවා ළඟදිනේ කරේ නේද? State machine ගැන මම ආයෙ කතා කරන්න ඕනද? State machine. So state machine or the state diagram shows for a particular scenario what are the state transitions. Actually, not a particular scenario, for a particular class. Say it's hotel room reservation system, maybe the class is a room. So room is in new state, room is in reserve state, maybe occupied. Okay. So we can draw a state diagram. Order, new state, confirm state, paid state, dispatch state. Sometimes it can go to the cancel state. Those are for state diagrams or state machines. It's behavioral or dynamic because different events can trigger state transitions. Okay. So you have states, then state transitions, two special states, start state and stop state. And again, make it very simple and short. Okay. So states must be sort of a nouns, and state transition may accompany it with a particular behavior. Optionally, but yes, sometimes it can happen. Okay. And state transition may have the following association: action, guard condition. And also state transition can trigger an event. So action and event are two different things. So action is something that happens during the state transition, like this: add student or finalize. Those actions. Guard condition is obviously a condition that must be satisfied to go from a particular state to another. Okay. And there can be event. So events are usually interacting with another outside object. Okay. So you can have do action. That means while in this particular state, this action can happen. Entry action means when you enter into this state, this action must be happen. Exit action means when you get out of this state to different state, this exit action must happen. Do means during that state, anytime this can happen. Right? And you can have special exit conditions, okay, exit actions. You can have exit points. So that means this is the last state. So these are two possibilities to getting from this to this. Right. So CRUD analysis. Sometimes we call it crude analysis. No, ඉතින් ගිය අවුරුදු paper එකෙත් අහලා තියෙනවා. Second paper එකේ. So CRUD or the crude matrix. C stand for create, retrieval or read, update, delete, and execute. So what are the operations? CRUD operations. for a particular object. When does the create object happens? When does the retrieval happens? Read. When does the update happen? Delete happens? Execute happens? So you can document. Okay. Right. So once you model your class diagram, package diagram, and so on, and then whatever the thing you need to verify and validate. Okay, this is not only for state diagram. Any diagram, you should be able to validate, verify whether it's consistent with other diagrams and so on. And of course, the component diagram is architectural diagram that shows what are the software components or modules and how they are related. Component diagram. This is the older approach. New approach is just use rectangle. So this is sometimes we can just show it like that, but some books they show the interactions like this, well-defined interfaces. That means this order system can call customer repository system or module. So deployment diagram is a special case of a sort of a component diagram, but we show in which way and which machines these components are deployed. And some more UML2 diagrams. One is composite structure diagram. Remember we discussed inner classes, nested classes. So one class is inside the other class, right? Internal structure. So inside person class, there are two inner classes called mind and body. So this is how you model it in UML 2.0. We call it what? Composite structure diagram. Then interaction overview diagram, because sometimes your activity diagrams can be very complicated. So therefore, in order to show the big picture, while your activity diagram shows the details, someone might want to look at the big picture. So therefore, your activity diagram can be supplemented by an interaction overview diagram. Okay. And of course, the timing diagram is when some activities happens when a particular time is elapsed automatically. A timing diagram can be handy. Okay. And UML profile diagrams are to extend UML to build your own type of diagrams. Okay. New type of diagrams. Right. So then we moved on to object-oriented design. We look at design patterns and so on. Remember, we can use UML for analysis, model at the analysis level, special use case diagrams, and then model at design level, like most fast diagrams, sequence diagrams. Remember, we can have structure diagrams like class diagram, component diagram, and we can have more dynamic diagrams, behavioral diagrams like state diagram, use case diagrams, and so on. Okay. Functional diagrams. Package diagrams we have already discussed. Right. So then we moved on to the last topic, uh, component-based software engineering. So we can develop software as set of components that are integrated using well-defined interfaces. It's a new way of software development. What is a component? It's a high-level abstraction of object or set of objects, okay, or related objects. So the idea is you reuse as much as possible components and develop the components which are not available, and then make sure that these components are properly integrated. Just like it's borrowed the concept from hardware, computer hardware, right? Computer hardware also we use component-based architecture, processor, RAM, printer, even screen, keyboard, mouse, but they can collaborate. Same concept can be used for software development. So mostly your component is a web service. And middleware can help deploying your components, communicate your components with other components and so on. So CBSC means develop software with the help of discovering and assembling existing components and then develop your own components if it is not readily available. So when it comes to software components, there are some challenges because some software components are technical, depends on the technology. For example, Enterprise Java Bean is a Java technology. .NET, there's no EJB, Enterprise Java Bean, rather they have their own COM objects. Okay. Somewhat new approach is expose your component as services. Right? Service means mostly web services. Web service or microservice. So about 5-10 years ago, it's web services. But these days we try to break your big services into small services, so maybe 3, 4, 5 small services and deploy. Then you call it microservice. So this is how you show the component interfaces. So you have the requires interface, provides interface. Make an example එක කෙලින්ම අහලා තියෙනවා. So your component require these interfaces, service of these interfaces. And you can provide these and these functionalities, but you need this and that you usage support. And these are some design patterns related to components like adapter and so on. So remember, these components can be technical specific. Maybe your component is a web service, or maybe it's a EJB, COM+, COBA. You will look at some of these, especially web services, EJB and COBA in semester for enterprise application development. Okay. Right. So then the middleware support for component-based architecture. So you need a middleware so that you can deploy your components, configure your components. Okay. It's like a container for your services. Right, so these are the classification of services. This is another famous past paper question. Horizontal services, platform services. Okay. So horizontal services are pretty much supporting services. They also have application independent services like logging, security, transaction handling. Those are support services. Okay. So the platform or the fundamental services are related to some functionalities. Okay. Right. And also they mentioned about how the computer-based software engineering process handle it. What are the tasks, subtasks? Right. So then what is mean by legacy system component? So that means it's outdated technology, but we are just keeping it because you don't have alternative. Okay. Legacy system component. Sometimes we need to communicate with these legacy systems through old approaches like COBA. Or we can expose it like a web service. And so these are the steps in component-based software engineering. So how do you do the integration sequentially, hierarchically, additive composition? So this is sequential and this is hierarchical. This is additive. Right. So definitely in Sunday class, we are going to straight away no revision because I did revision. Now you have one more day, Saturday, so 2 more days, because we are going to start with 2024 MCQ and structured. Then we'll move on to 2023 MCQ and structured, and then 2023 MCQ and structured. But you can do at least 5 papers. I will do 3 of those, the latest 3. Okay. Right. We stop at this point, right? Thank you.